Hello and welcome to the ACEC Civil 3D User Group. My name is Keith Sawinski. I'm with the Wisconsin Department of Transportation in the Methods Development Unit, and I'll be providing an update on what's been happening at WisDOT. I'm going to focus my update on what's going to be coming out in next month's Civil 3D Standards release. We're going to have a lot of sub-assemblies that we'll be introducing, and I just want to run through kind of what that's going to be about. We're releasing all the sub-assemblies you see on the screen here. We're going to have a new lane sub-assembly that'll replace lane generic, and it will be called lane extend base. We're going to have a new shoulder. It'll be called shoulder generic. A new curb and gutter sub-assembly, which will be called CG basic. And then we'll have a new daylight sub-assembly. This sub-assembly will be one to replace the current Gen CF. We're calling it daylight profile controlled. And then we're going to have a new median sub-assembly that can either do a ditch or a berm. In addition to that, we're going to have several additional generic sub-assemblies that you see on the right. I won't get into details on those, but we think they're going to be helpful to people. So some of the highlights with the new sub-assemblies and some of the things we're trying to accomplish. First, we want to repair any defects that we knew about with our current sub-assembly library. For example, everybody's aware of the vertical face issue with our surfaces if you were to use our curb and gutter sub-assembly. And without any modification, you wouldn't be able to form that nice clean vertical face without adding an additional link width and slope or something to fix that vertical face. Other things like Gen CF would sometimes crash Civil 3D if your ditch profile happened to go above your existing terrain. So we went through all the defects that we knew about and tried to correct as many of those as possible. And next, we wanted to improve workflow, make things as easy for folks as possible to create models. Things like adding profile, slope, and width control. Right now with our sub-assembly library, we have that profile to parameter ref sub-assembly, which is really great to be able to use a profile to define a sub-assembly's slope or width. Well, we're taking that functionality and we're building it into all of the sub-assemblies where we see fit. The example you see on the screen here is our new daylight profile controlled. Basically, every slope that sub-assembly has, any link, you'll be able to control that slope with a profile. And we're applying that to as many sub-assemblies as we can. Our new lane extend base sub-assembly, for example, you will be able to control the lane cross slope with a profile. In addition to that, we're exposing all point, link, and shape codes to the user. So when you go into the sub-assembly properties, you'll see, as you can see on the right side of the screen here, all the point, link, and shape codes, they can be edited. So there's a lot of uses for that. A couple immediate benefits that you may realize is simplified labeling of your corridor sections. You can add the code that triggers a label right to the point or link right in the sub-assembly properties. Other uses, one could be for quantity takeoff. You could have uses related to visualization. There's really a lot of benefit to exposing those codes to the user. Next, we want to simplify the sub-assemblies as much as we could. Nobody wants to spend time reading 15-page sub-assembly help files. Sometimes it's necessary, but we wanted them to be as intuitive as possible and just kind of work for people. So the first thing we did is we looked at our subassembly library, and we combined subassemblies where it was logical. You know, the examples I have shown on the screen here, we had 2 lane subassemblies, 1 lane generic and 1 lane mark point. We combined the functionality of both those into lane extend base. And we did the same thing for the shoulder, the curb and gutter, and then we had some subsurface excavation subassemblies that we're able to combine too. So if you count them on the screen there, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 subassemblies. We've reduced that to 4. So there's no longer that question when you're building your assembly. Gosh, you know, which subassembly do I need to use here? There's 4 shoulders. Well, now you'll know. Just use the shoulder generic, and all that functionality is built in. The other thing we did is a lot of the subassemblies had these manual switches, which would kind of trip people up. The example on the screen here is subassembly properties for lane generic, and there was that one parameter called outside lane elevation method. And this, if you happen to want to target a profile for your edge of travel way, you have to remember to flip this switch to profile. Well, that would often trip people up. Instead, we've built the new subassembly so that if you target something, well, you must want to use it for something, right? You don't have to go and tell Civil 3D twice that you want to target a profile. You don't have to flip a switch in the properties and then go ahead and target. Just target it. If you target the profile, then the subassembly will find it and it will use the profile. So the way this is going to show up after the update, all of our old subassemblies that are being replaced are going to move to a new palette. It's going to be called a legacy palette, and there you'll see, you know, all the subassemblies that have been replaced. And when you hover your mouse over these subassemblies on the palette, you know, you'll get a tooltip, and on that tooltip, well, it'll say right on there, this subassembly has been replaced by you know, whatever the new subassembly name is. That way, if there's a question of, you know, okay, I used to use lane generic all the time, now what am I supposed to use? If you just hover on that subassembly, it'll tell you what the new one, what the new name of the subassembly is, and you can go ahead and find that on the other palettes. These legacy subassemblies will remain on the palette for Civil 3D 2016. But in our next version of Civil 3D, Civil 3D 2018, that palette will be removed. You'll no longer be able to access the legacy subassemblies through the palette. Our wis.build will still include the source files for those subassemblies. So if you open an old Civil 3D drawing that used these legacy subassemblies, it'll still function because the source code for those subassemblies will be included in the wis.build. Also, going back to, you know, reading help files, you know, there's a lot of details in these help files, and a lot of it's very useful information, you know, when you need it. But sometimes you just need a summary of the subassembly. So for most of these subassemblies, we're going to include a video. And you know, the simple generic ones that were the subassembly help files only like a page long, we're not going to have a video for that. But you know, the more complicated ones that are have a lot more parameters, those will include a video that you can watch just to give you that, you know, get me started sort of rundown of what the subassembly does and how it works. And then finally, we have a whole host of assemblies on our assemblies palettes. We're going to rebuild those palettes completely. Those assemblies will be all be rebuilt. There's some that are even obsolete on there. We're going to clean that up, and we're going to rebuild the assemblies with the new subassemblies, so you can kind of take those and run with them. So that's what you have to look forward to next month. I really hope these subassemblies are helpful to you. We put a lot of effort into it, and Got a lot of feedback from our users, and I think it's really going to help people out. Because of the holidays, the Civil 3D update probably isn't going to happen on time. We're going to have some delays due to time off for the holidays. So we're looking at probably the week of 1/15 for the Civil 3D update to go out. We're going to try to get it out as early as we can, so maybe we'll get it out a week earlier than that. But look for the week of 1/15 and go ahead and download the standards and dive into those new sub-assemblies. I think you're really going to like them. So with that, thank you for your time. We're going to hand it over to Paul Kirkendall now, and he's going to dive into the rest of the presentation today. Thank you.
Hello and welcome everybody to the ACEC Civil 3D Users Group. Today's topic is going to be calculating and reporting material quantities and volumes in Civil 3D. This presentation is going to be recorded and will be available for future playback at the link at the bottom of the screen. My name is Paul Kirkendall. I'm a Civil Solutions Specialist at Master Graphics. If you have any questions on today, the email and phone number I can be contacted at any time. We also have the mastergraphics.com website that you can go to for further information about Master Graphics. Today's agenda: we are going to cover corridor, earthwork, and surface volume tools, mass haul diagrams, and pay item quantities. Wisconsin DOT does not have a specific workflow for QTO. They have not yet implemented a comprehensive QTO workflow concept, and in the absence of a comprehensive solution, I will be demonstrating workflows that use stock tools and functionality to realize benefits that are readily available in Civil 3D. A note from WisDOT that I have for you is WisDOT sees potential for even greater benefit from a customized QTO workflow implementation that is developed specifically to their project needs, but they continue to balance the priority of a QTO development effort against other work. WisDOT has not yet set a timeline for a QTO implementation effort. For the immediate future, it will not be actively worked upon, as they are presently focusing on higher priority work. Having said that, I am going to use some of the WisDOT styles and features and their pay item lists. I'm also going to use some out-of-the-box Autodesk and some that I have manipulated. So as we go on today, you'll see some of both. So now I'm going to go ahead and dive right into Civil 3D here. In Civil 3D, you can see that I have a drawing open, and in the drawing I have XREF of corridor drawing. I also have a data shortcut of the existing surface, corridor top surface, and the refinement datum. So we're going to start off with QTO criteria. I'm going to overview that. But like I said, I have that data in here, and I have created sample lines to cut through for my sections, and then I have created section views. And if you can see in here, I have the existing surface and the proposed surfaces in here along with the corridor. So we can do a few different computations of quantities based off the surfaces, and then we're going to do a computation of the corridor quantities for the corridor shapes. So first off, I'm going to go into the tool space, and we're going to go ahead and look at some of the settings of the QTO. So in the quantity takeoff, there is a quantity takeoff criteria. Now I brought some additional quantity styles in here, but the WisDOT mass ordinate is the one that WisDOT has created. So we'll go ahead and look at that one first. So this one has a bunch of materials for surface quantities. So we have a cut common, we have some marsh, We have some embankment, marsh, rock, and then EBS. So we got the subgrade, we got some excavation. So if you have any of these surfaces, those can be brought in as well. You also have quantity type, the cut fill factor, the refill factor, and then your shape style. So if I click on the shape style, we're going to look at that in a minute too. The shape style in this particular one is going to show in plan as just a border line. If I go in my section view, it's going to show the same as a green border line. And that's part of the material list. We'll get a little bit deeper in a second on that stuff. I also have a cut and fill and earthworks and then a material list. We'll go through those in a second after we do the WSDOT mass ordinate. So to do quantities, we need to go to the Analyze tab, which I'm already on. On the Analyze tab, we can go to Compute Materials. We're going to have to compute the materials before we can create any kind of table or report or mass haul for that matter. So go ahead and compute materials. I need an alignment and a sample line group. So the alignments and surfaces I brought in, and I created sample line groups. If you need to know how to create alignments and sample line groups, you'll have to look at some previous videos on WSDOT training. Go ahead and click OK, and my compute materials dialog box is going to come up. On this box, you'll see that I have surfaces, final datum, and existing, and then I have the other surfaces that I just showed earlier. We're not going to have any of these bottom surfaces here, but we do have an existing surface in here. So I'm going to click on my exist for my existing surface, and it's going to fill in all of the existing surfaces for these areas. And then I have a final datum. I'm going to use my refinement datum, and that's going to fill in here. I don't have any of the other surfaces, so we're going to go ahead and we can click OK. One other note before I move on is this volume calculation method is average end area, which is what the DOT requires. However, if you would like to do a prismoidal or composite volume, you can do one of those as well. I'm going to go ahead and click OK, and it's going to give me a little warning here saying not all the named surfaces or shapes have been mapped, and that's because I left some of these empty, which is fine, we don't have them anyways. Go ahead and click OK. Wait a second or two, and then we have our materials. Some cut fill show, but since that mass ordinate is just the green background, we don't show anything other than the green line. Okay, I'd like to see that a little bit more kind of in my face, so to speak. So I can go into my section view and go to View Group Properties. And in there, I'm going to see a cut common and an embankment now. And the style right now for those is WSDOT standard. I'm going to change that style for the cut and fill. So the embankment is going to be the fill. We'll change that to fill material. And the cut common is going to be set to a cut style. If we go ahead and look at these styles, I'll show you what we did here. In the display, under section view for the view direction, I would like that to show as a transparent color in green. So that's what we set that to. I believe by default it is off. I just came in here and turned it on. Click OK and OK, and then the embankment if I look at the fill under section view, you have the same thing. Under the cross-section fill layer, it's red, transparent. Now if I go ahead and hit apply and OK, now the cut and fills are going to show up in all of my section views here, and you can see how exactly that's going to tie in visually to each section. So I have those cut and fills assigned and showing. Now I want to go and create a shape material for the corridor itself. So in here, let's say I want to compute materials again. I have the alignment and sample line group. So this list, I'm going to change the list to cut fill. If I can type here, fill, hit enter, and now I can either add to this or import another criteria. If I click on import another criteria, there are some other criteria listed here, and I already have one set up. I created a material list, and we'll go ahead and add material list. Click OK, and you can see on the list it's going to add all these corridor shapes. So I have added some of these corridor shapes to this particular criteria, and now I can map objects with the same name, and it's going to fill in as many as it can according to the names. And then I can come in here in this subbase material. We're just going to make this the other subbase that's not populated already. The base is going to be the base, and then pavement is going to be pave 1. So I have all those filled, and go ahead and click OK. It's going to add it as a new list in here. We're going to call this corridor shape materials. And you can see the quantity type is going to be a structures. So let's say I wanted to add another one. To show you how to add that corridor shape, there is a data type up here. Click on that, and then you have the different data types that you can add to this list. So you can do that manually one by one, or you can import the criteria if you already have that developed. And then each one has a sub of the actual link that is in the corridor. I'm going to go ahead and click OK. Now to back up before I show you what's going on, I'm going to go back to my tool space, and in the settings under quantity takeoff criteria, I'm going to double click on that material list, show you that this is where you can add new things to your material list. Now quickly you can add surfaces or corridor shapes. So if I wanted to add a corridor shape, keep in mind that the quantity type has to be structure if you want to add a corridor shape, and if it's a surface, it has to be a surface type. You can also define from a sample line group, so that'll walk through the sample line group and add in the material name. So now that we have the materials, if I look in here, the materials I have set to automatically populate. Now it would probably be a good idea not to have both of these in the same sections, so I would create another section group down there so I have my cut, fill, and my quantities, but they're not necessarily in the same section. So I can see them visually different. Although if I do need them, I can see where things overlap. So now what I can do is I can create total volume tables and reports. I am going to add a table to each view. So there are a couple different ways to add these tables. You can add tables in the views and then add tables to just a separate one-shot table. To calculate the material table in section view, I'm going to go ahead and scroll in. I'm going to grab my annotation. I'm going to go up to my view group properties, and in there under my section views I have change volume tables. I'm going to go ahead and click this little radio button. In there I can add a material type. I'm going to go with the total volume, and then what's that standard? We're going to add that. Notice that the material list comes up automatically, and then I need to adjust it so I have it in the right place. So for this one I'm going to try middle center, top center. It's going to be horizontal, and then we'll just see if -0.5 will work. And notice that I have this dynamic, so it'll update for me if things change later. And then I can go ahead and click OK. And we'll see here that I have a table that shows my cut, fill, cut volume, fill volume, cumulative, cut, fill, and then my net. And for each section, this is obviously my first one, and then so on and so forth. I can keep going. So the next kind of table is going to be just a table that has the materials. So if I go up to my Analyze tab this time, I can go Material Volume Table. In that Material Volume Table, I'm going to select the Width.Standard. The alignment is the only one I have in here. Same with the sample line group. The material list is going to be this corridor shaped materials this time. I'm going to select a material. We're going to select pavement. And then I'm going to leave all the rest of it the same, or default. The reactivity mode is going to be dynamic. So I'll go ahead and click OK. And it'll ask me to place it. Now I can see in here that this is my pavement by volume numbers as I go down the corridor. Notice that it is only one material, it's just the pavement volume material. So for each one I'd have to do a separate table. Now an alternative to that is going to be a table report that I can link in Excel and bring back in. So go ahead and try that quick. The volume report, I'm going to click on the Analyze tab, and I can change this to corridor shape materials. And then for select a style sheet, I need to go to my C drive and get that. And I am going to use select material. I'm going to open that, and I'm going to click OK. It's going to say that scripts can't be used, and that's fine. And now you'll see in here that it's going to give me each area type and then the volume for each. And I have the whole table for each shape in here for each section. So what I want to do is I'm going to go ahead and copy all this with a copy, and then I'm going to go to Excel. I'm going to open it up, and then in here I'm just going to pick a blank workbook. We'll paste that in here. Actually, I'm going to undo. You want to make sure that you paste it to match the destination formatting. That's going to be your best bet here. And then you can see here that I have everything in here that came from that last report. So what I can do with this is I can link it back into Civil 3D. Go ahead and save it. I'm going to save that in my design quantities detail reports for earthwork. Save that in there as number 2 so it doesn't override my last one. Close all those out. And then I can come in here and I can create a standard table and link that into it. So we'll go ahead to the Annotate tab. I'm going to go to a Link Data table. Under Tables, I click Link Data. I need to create a new Excel data link. I'm going to name that Corridor Shape Materials. Click OK, and then it's going to ask me where do I want to go and get that file from. So I'm going to browse to my corridor material quantities. I'm going to leave it a relative path. It's going to be the first sheet. I want the entire sheet, and usually that's going to be too big for a preview, so it's not a big deal. Click OK, and then once it populates the link name, file name, and then the details, I can go ahead and click OK. So from there I can go ahead and insert it into a table. So I'll click on the table, go from a data link, and then select the data link. I already created that, so I'm going to go Corridor Shape Materials, click OK. And I have my table populated, and it'll work just like any other table in Civil 3D. Change the size, you can add things to it, and you can see that it's a data link. And if you update that table in Excel, it'll update your table here. So from there, we're going to move on to working with mass haul diagrams. Now what you need for the mass haul is alignment, 2 surfaces, the sample line group, and the materials list. So since I already have my materials list in this drawing, and my alignment, 2 surfaces, and the sample line group, I can go ahead and go on from here. Save the drawing first. If we go back to the Analyze tab, there is a mass haul that we have here. I'm going to go ahead and click on that. That is going to ask for the alignment, the sample line group, the mass haul view name. We're just going to make this mass haul balancing. And the mass haul view style, we're going to make that WIS.standard. Go ahead and click next. On here, I'm going to do the cut fill for the material list, and the total volume is going to be the total volume. I could do the cut, fill, unusable volume. We're going to do total. Then the mass haul line name is just going to be mass haul line. We're going to leave the mass haul line style the way it is, and then the free haul distance, we're going to make that 350. You can also add a borrow pit or a dump site to help balance your site out as well. I'm going to go ahead and say create diagram, and I'm going to add that down here. And there you can see the mass haul diagram with the Wisconsin DOT style. We'll go in here and go to the mass haul view properties. I'm going to change this to the standard. You can see that not much changes. If I go to the mass haul line, change that one to standard. You can see that it changes a little bit there. So we have our mass haul. So last but not least, we're going to go through the pay items for quantities. So the pay items have been added to many things in here. Specifically, they have been added to the pipes and the pipe networks. So I'm gonna I have another file I have opened in here, the pipe storm sewer. In here I have some pipes and some culvert ends, culverts. I also have some inlets and pipes connecting to those inlets. Now, the pipe networks parts lists in the WIS.Civil 3D template already have the pay items set to them. So if I go to Prospector and then go to pipe network, go to parts list, in there I'm just going to go to this culvert one. You'll see here that if I go to, let's say, apron end wall, you can see that the pay item is already placed in there. So it has a paid item currently on it. So if I run my pipe network, I can get my quantities of the pipes and any structures already done. So if I lay out my pipe network, and then I can go to a takeoff report. If I go ahead and go to my Analyze tab, go to the QTO panel and click Takeoff, I have a detailed or a summary, and then it's going to be the drawing extents, and then I can say report selected pay items only, which I'm going to add that alignment to it. And then I'm going to go ahead and hit compute. And you can see here in my report, it has the pay item ID, the size of the structure or the pipe or whatever it is, description, quantity, unit, baseline, station, and offset. So these are all the pipes and structures that I have in this drawing. And there's my report. I can change this report to a CSV. The detailed count. So you can see here there's a difference. We have detailed area, count, linear, or detailed volume. So we can go ahead and go linear count. And then we'll see here. And I can draw that out. I like the HTML of this particular one. I can go ahead and click draw. When I do that, it's going to fly me out to the drawing. Click in there, and then I can have that, and you'll see here that it's going to draw it in. Go ahead and go to the linear, and you can see the difference. It's going to give me the linear, not just the count. If I draw that, set that one next to it. I don't have anything for volume in this one, so it's not going to show anything for volume anyways. As you can see here, that kind of goes away. I can also save it out as a CSV file and bring it in as a table, but this works pretty well as my table, and I have a count for each structure, and then for each culvert pipe I have numbers for that as well. Now to go a little deeper into the quantity pay items, I'm going to go through adding it to a corridor. So I'm going to flip back to this other QTO drawing here. I flip back to that one. And I'm going to add them to the code set style. So if I click on my drawing and then multi-purpose styles under general and then go to code set styles, I have created one that is cross-section with QTO. If I double click on that, in here on the codes tab I have the links. I also have the shapes, which I cannot add pay items to. I add them to the links. And then I can add individual QTO to specific items in here. So if I click on, let's say I want to add a pavement or maybe concrete for sidewalk, so I can click in where it says none, click on the little dump truck here, and then you have a list here of specific things that you can add as a number. So you can also add things to favorites. So I have a favorites here, it has a bunch of stuff in it. That is per drawing to add to the favorites. But if I, let's say, go to pavement and I have concrete pavement, underneath there I know that this is going to be 6-inch pavement. I can go ahead and click on that to add that to this sidewalk. So if I click OK, that's going to add that to the sidewalk. So in this particular spot, I can't add things to my favorites. The only place I can add to my favorites is going to be from my panorama, and then it will be in the favorites, and it'll be easier to select. So I can go through that stuff. If I don't know the numbers, I can add them to the favorites. So I can go through and add all these pay items to each particular link, whatever I need my quantities for, and then I can click apply, click OK, and then when I do a quantity report, I can do when I do a quantity takeoff report, I want to keep in mind that quantities for pay items that are associated with the corridor codes are not calculated in a summary report. So I have to do a detailed report. So that'll give me area, the count, and linear. If I go to my takeoff and I say detailed, now I want this to be the drawing, and then I am going to select the STH 25 best fit. Make sure that I pick the cross section, 2016 drawing, and there we go. Make sure I change this to a detailed count CSV, and I can see in here that I have, let's go to HTML, it looks a little better. I have for each pay item the description, the quantity, the unit, the station, the baseline, and then the remarks. I have my surface. So these are all the pavements and the subbases that I have assigned to pay items. So the same thing goes with this. I can go ahead and say draw. I can add that table to my drawing. And that one was for the detailed count takeoff. So I can go ahead and close that out now. Close my report out. If I come in here, I can look and I see that I have breaker run, the quantity, the unit, and then the baseline and the remarks all in a table here. You can also bring that out to a CSV, like I said. So if I click on that takeoff, go to compute, so we'll go to the account CSV, if I go to a save as, it's going to allow me to save that to a CSV, and I can bring that in as a linked table too, just like I brought in the table in the previous exercise. Go ahead and cancel that out, close. So one last thing before I'm done, if I go back into my panorama in the QTO manager, a couple things to show before I finish here. If I click on the left drop down, it says open pay item file. This pay item file is in the WIS.dot folder, or in a WIS.dot folder. If I go ahead and click find that folder, you can see here that there is a WIS.dot folder, pay item data, United States, and then WIS.dot under C drive, as you can see here. And that'll bring you to the CSV for that data. There is also a pay item categorization XML in that folder that you can add as well. They are automatically in the WIS.dot one, WIS.dot template. You also have a AASHTO and a Florida DOT in there if you want to look at that as well. So going back to that panorama, you can filter by a number. Let's say if I knew what number I wanted to be, I could filter by that number. In order to do that, I want to turn off my categorization. And then let's say if I add 601, click search, there we go. I go 521, Now you can see that all the 521s are here. So I can right click on one and say assign pay item or add to favorite list. And then things will show up in my favorite list. If I turn my categorization back on, then that entire list shows up with everything in it. I need my categorization off in order to search for specific things that are in subfolders. You can also add pay items through this little add here, and then select the item that you want. So if I wanted, let's say, clearing and grubbing to be assigned to this entire surface here, now when I hover over it, you can see that the entire pay item for clearing is assigned to that surface. If I had just some areas that I wanted to have for maybe grubbing now, assign pay item, select that, and when I hover over it, that's going to be my grubbing. Even if I move it, it's still assigned to that particular item. Thank you everybody for sticking in there with me through that topic. If you have any questions, feel free to let the power user know. Shoot me an email or give me a call at the number in the PowerPoint. Also, please fill out the evaluation survey and have a great day.